Alright everybody, here's our last video for Unit 5 on quadratics, and today we're going to take a look at the model of best fit. So we're going to look to see, do we use a linear model to represent the data, a quadratic, or an exponential? And we're going to use our calculator for this, so you will need your calculator. So we've looked at three types of models so far this year. We have looked at a linear model, which is y equals mx plus b, and then once we enter a set of data into our list, our stat, our list 1, list 2, then we go to stat calc 4 to give us a linear regression. We've also looked at exponential, that was unit 4, y equals a times b to the x. Same thing, stat calc, hit 0. And then lastly, last night we looked at the quadratic regression, y equals ax squared plus bx plus c. Same thing, stat calc, but this time it's number 5. So each of these models can be used on any set of data. However, the best model is the one that goes through as much of the data points as possible and yields the best predictions. Now, we have used R when we looked at for a correlation coefficient for linear and exponential. Quadratic doesn't have an R value, it uses an R squared value. So to compare apples to apples, we're going to use R squared when we're looking at our correlation coefficient. So which model will be best for the following scatter plots? So if we traced our line here, or our curve here, this would be a quadratic model. This is a straight line, so that would be a linear model. And this is an increasing exponential curve. So we're going to take a look at bacteria growth in question number 1. Our x is measuring the time in hours, and our y is measuring the number of cells. So at 0 hours we start out with 50 cells, 1 hour, after 1 hour there are 71, 2 hours there are 100. So we're going to put your data in your stat editor and plot it. So you're going to hit stat, enter, and then in list 1 is going to go the number of hours, and in list 2 is the number of cells. And then we are going to find the linear regression. So we're going to go to stat calc 4 to find the linear regression. So I'll give you a few minutes to do that for linear, exponential, and quadratic, and then you can pause the video, do that, and then check back with your answers. Okay, so hopefully you got these equations for your linear, exponential, and quadratic model. Our linear model was y equals 45.51x plus 27.05. Had an r squared value of 0.941. And again, we're using r squared because our quadratic model does not give us an r. Exponential, 50.06 times 1.414 to the x. R squared of 0.999. And quadratic, y equals 7.68x squared plus 7.12x plus 52.64 with an r squared of 0.998. And if you look at the starts on whether it's linear, exponential, or quadratic, what our y-intercept is, for linear, the y-intercept was 27.05. Our table gave us 50. Exponential, it was 50.06, which is much closer. And then quadratic, our start was 52.64, which is closer than the linear, but not quite as close as the exponential. So if we look at our r squared values, we're looking with the highest r squared, and it looks like exponential and quadratic were neck and neck. However, exponential was the winner because it was 0.999. It was closer to 1. Not much, it wasn't off very much, but it was definitely closer to 1. So which model do you think would be the best fit and why? Well, exponential, because it has the highest r squared value, or the highest correlation coefficient. Okay, go ahead and try number 2 on your own. The chart below shows the weight of a fish in thousands of pounds caught in area lakes for 6 consecutive years. Which model would fit this data the best? And then once you conclude that, graph the model you chose and find out which value of t that the amount of fish caught would be 6,700 pounds. Use trace or check your table. So pause the video. This will go in list 1, and this will go in list 2. Okay, so when I put in my linear regression, I got an r-squared value of 0.15 or 15 hundredths. When I put in my exponential regression, I got r-squared equals 17 hundredths. And then when I put in my quadratic regression, I got r-squared was 98 hundredths. And clearly, this is the winner. So my equation, my quadratic regression, is y equals negative 0.37x squared plus 1.616x plus 13.596. And when I put this into my y1, I used the vars key to make sure I included all those decimals so that I would get an accurate reading. So in letter B, which model did you choose? We chose quadratic and y, and so it's asking you when y is equal to 6.7, what's our x value? What's our elapsed time in years? And why 6.7 instead of 6,700? Because our weight is being measured in thousands of pounds. So it's 6,700 pounds. As a decimal, according to our list 2, our y values, it's 6.7 pounds. So I just went to second in trace, or second in graph, and looked to see when y was equal to about 6.7, and that was somewhere around 7 years, and 7.03 years to be exact. Okay, now it's your turn. Multiple choice question number 1. We have the year is X and the number of doctors is Y. If a linear regression model is the best fit of this data, which equation would best represent the data? And we're entering X as the number of years after 1960. So this would be X equals 0, this would be X equals 7, X equals 10, etc. So use your linear regression model, stat calc number 4, to figure out which of these equations, linear equations, best models this data here. And number 2, the table below shows the amount of substance remaining after each half-life of a substance. The number of half-lives is here, and the amount of grams remaining is here. What type of model would fit this data? So what I'm asking you, would it be a linear model? Would it be an exponential model, or would it be a quadratic model? Be sure to enter your answers in the Google form. And if you have any questions, put those there as well. Have a good night.